Alright, so what we've done is we created a program that opens a file and displays it. I'm going to make it open itself. The file is called file1.py in my program. File1.py. So that's the file that I'm opening. We declare a line number variable and initialize it to 0. For every line of code, every line of the file we read, we add 1 to that line number variable. We strip the spaces off the end, off the right side of that variable, and then we print it out, the line number followed by the line. Once this loop is done, we close the file. That's our story till now. Let's run it, make sure it all still works. Yeah, so it's opening itself and displaying it. If you think about it, it's kind of interesting. You could write a program that would write a script and then execute it by calling Python, telling it to run that py file. So going back to chapter 7 here, we've seen how to open a file and read it. This is the syntax for doing that. This one only counted the number of lines. It didn't print the data out. So they initialize count equal to 0. Every line in there, they increase the count by 1, and then at the end of it, they print the count out. So this variable here, fhand in their example, f in mine, is what's known as the file handle. Handle meaning that it's the way that that file is referenced. Handle has a very specific term in Windows programming and some other programming languages. It's a resource. Back in the old days, you'd worry that your program would run out of handles. Don't know if you've ever used Windows 3 or Windows 95, but you could get to the point where Windows no longer had any file handles and you had to restart it because you used them all. And we don't have that kind of problem anymore, really. There is a .read method that'll read the entire file into the variable rather than just line by line. We could do that. Let's open a new file after our f.close, or even the same file again. And then read the whole dang thing in. Text is equal to f.read. Print that text out. Now we're going to get 2 copies of our text, obviously, if they're the same file. And then f.close. Alright, so the first time it read it in line by line, and we have our line counter proving that. The second time, this entire bit of stuff, from here all the way down to the end, is all stored in that one variable. So f.read read the entire thing in, whereas this syntax, using a for loop, reads it in line by line. Which do you want? Kind of depends. If you want to process it line by line, this is the ideal syntax. If you want to open it all at once, like what about our sentence analyzer that analyzes the count? It'd be kind of neat if we just read it in all at once. Once you've read it in all at once, you could break it up, you know. You could split it up by spaces or something like that if you wanted to extract all the words out of it. So to search through a file, you might want to plow through that file looking for a specific line, in which case you can use those things like starts with or in, you know, in, if something in something. We have been using print statements a lot, so if you're opening py files, I bet some of these have print statements. So let's do this. If the word print is in our line, print it out. We are filtering the file. We're only going to print out the lines that have the word print in them. The second time, we're not doing any such magic, so it prints the whole thing. Here's the first run, though. There were only 3 lines in this file that had the word print, so those were the only lines that displayed them. Line numbers 9, 10, and 16. We could go over here and verify. Is that line number 9? Let's find out. Yeah, it is. Okay. Does the word print occur in the line? Exist in the line? That's what that did. I don't know if y'all have ever heard of a grep utility. But grep, G-R-E-P, will open a specified file and search it for a specified string, and it will only print that line of the text out if that word exists in it. And it supports what are known as regular expressions, which are ways of, like using an asterisk or whatever to match, a certain number of characters. So we could write a grep utility where you specify a file and you specify the string to search for. It would open that file and it would print only the lines. So as your file processing programs get more complicated, you may want to structure your search loops using continue. The idea of the search loop is that you're looking for interesting lines. You want to skip uninteresting lines. As soon as we find an interesting line, we want to do something with that line. So here we go. They've structured theirs like this. If not starts with from, continue. What does a continue do? It just loops back up and it repeats the for loop without doing anything else in the for loop. Reads the next line then. Well, I did the same thing just by using if, something in, and I didn't use a continue. Whatever. I rarely use continue. Here they're showing an example of searching for a specific string. Different way than I would have done it. I used that syntax if word in line. Here they're using .find. What does .find return if the word that it's looking for exists in the string?
Does it return what it was looking for?
Well, it returns the index value of it. Like if you tell it to find an F and the string begins with an F, then that's index value 0. If it doesn't find it, it returns -1. So that's one way of writing an if statement that would, check to see if this exists in it. What I would have done is if this stuff in line, because this syntax is a little bit more neat, just a little bit longer, but it totally works.
You can put the continue statement on the same line.
Yeah, I was just noticing that. I was going, stroke my beard. Okay. Yeah, apparently you can. So letting the user choose the file name. We just provide an input statement. Fname is equal to input, enter the file name. I think it'd be more fun to let them provide a output file name so that we could copy the file. Here we had a separate one. The second time we opened it, let's ask them for an output file name and we will write whatever we read into a new file. So far we haven't seen how to do that. So writing files. When you open the file, you can specify a file name, but you can also tack on this optional parameter. If you put quote W, it means write. So up here, or after here, let's do an input statement. I'm going to call it outf for output file. Is equal to input. What file do you wish to create? Now we're going to open that file. All right, I don't like the way that works, that looks. I actually wanted to use outf for my file variable and not for the name of the file. So delete that and make it fname for file name, something like that. And then outf is equal to open that file name, but we want to open it for writing. If we try to open a file for reading that didn't exist, it'll generate an error. And you can use try and except to handle that error. We don't care if that file exists when we call a file name with a write. It's just going to blast it if it does exist. It's going to overwrite it. Now, a nice program would go, are you sure you wish to overwrite that file? We're not that nice yet. So now let's write out that text that we just read in. So you call .write. They call theirs f-out instead of outf. Outf.write, all that text that we just read in. And then outf.close. After this is done, whatever file we just read in should be pretty close to being an exact copy of the script that you've been opening each time. Alrighty, I'm not seeing that it did the input statement. Print, run message. Hello.
Really even still doing that?
Well, let's put a print statement after, well, okay. Print, yo, sup. Print, done. Seems to be something at the very bottom there. Well, what do you know? What file do you wish to create? It was there, it was just at the bottom. Tell you what, let's comment out that print statement. That's what's kind of causing the trouble right here is when we print all of our data. So comment that out. Let's get rid of that print statement, and we really don't need yo sup either. What file do we want to create? I'm going to call mine copy.txt because it's a copy of the original file. Done. Now I'm going to go out to my directory and see if that copy.txt exists. And it does. Here's copy.txt. So if I open it, it should look just like the code we've been editing. Cool deal. We are now file masters.
Where does it save it?
Same directory that your script is in, unless you specify a path or otherwise manage to change the directory.
Oh, I see what I mean.
So this one being kind of, I don't know. I think I don't want to add any more to this specific one. Let's make a new one, call it file2.py. Let's print what the program does. Pound sign, my name, etc. Print. This program creates a series of square numbers. Then let's ask for the file name. File name is equal to input save output to what file? Question mark. Now, how nice do we want to be? Do we want to check to see if that file exists? And if it does, tell them that we're not going to overwrite it? Nah, we're just going to erase it. So let's go ahead and open that file. I'm going to use fout instead of outf. It does not matter. Fout is equal to open file name, comma, write, W. And how many squares do we want to write out? I don't know. Let's write out the square of all the numbers between 1 and 1,000. So for x in range, 1 comma, if I want to go up to and include 1,000, I better make it 1,001. Now fout.write that number. I probably ought to convert that number to a string before I write it. So I'm going to do that. S is equal to strx. We've always been converting from strings to ints and floats. Now we're doing the opposite. X is an int. We're going to turn it into a string, and then we're going to write it out. F.write x, x times x, x to the power 2, something like that. We're going to write the square out. Or let's write out the original number plus a space plus x times x.
Is that one gonna work if you put f.write, it doesn't have to say f.out.write?
Yeah, I've goofed this out. That's totally messed up. Delete what I just did, and let's make it simple. Fout.write, and write that string out. That's enough.
Write out the new string?
Right.
Okay.
And then let's close the file. Fout.close. I'm going to call this one file2.py. Save output to what file? I'm going to call this squares.txt. And it blows up. I got the error, file does not exist. Oh, and that time it worked. I don't know what I did wrong the first time. I must have typed in invalid file name, something that broke it.
Okay.
So if I go look for squares.txt, this should contain our data. It's not going to be formatted in what we might hope to see. Well, that's kind of cool, but what do I really want to make this look better? I want line feeds. So I'm going to print out some /n's. And the other thing is that I promised the program was going to print the squares, but it's not. So I'm going to print the string of x times x. And then I want to tack on a /n. So that's going to be my output. /n meaning go to the next line. Let's go see what we got. There we go. There's all of our squares. Let's write another program that'll open a file and add up all the numbers that are saved in it. could just tack it onto this one, huh? Let's do that. Input,
Why
okay.
do they return everything with a slash in?
You got a backslash in, it needs to be the one above the enter key.
Okay.
Yeah. When you do the slash in, it has to be the backslash, which is the one above the enter key. That's what's known as an escape sequence. Anything with a slash in front of it like that is a special thing. We don't see that backslash thing, and that has some consequences. If I had a directory that looked like this, don't type this, but C:\\new files back, whoops, see here I'm using 2 backslashes, just out of habit. myfile.txt, and if we tried to open it, it's very plausible it would try to open that. I don't think, anyways, never mind, I'm going to skip that for now. Let's open a file. Let's ask them what file we want and add up all the numbers. So, file name is equal to input. Add the numbers or sum the numbers of what file. Now we're going to open it, but we're not going to open it for writing. And we're not going to call it fout because we're reading from it. So fin for file input is equal to open file name. It's possible that file doesn't exist. Let's actually handle that. Let's be good programmers. So the syntax for that is going to be this. Try the open. If it fails, print file cannot be opened, and then call exit, which is just going to kill the program. So here we're going to do try, colon. We need to tab that one open. Except, if an exception occurs, we're going to print could not open, comma, file name. And we're going to exit, kill the program. Now we can continue on our merry way and process it. We're going to need one of those for loops, and we're going to need a sum variable. Call it total. Total is equal to 0. For every line in our input, excuse me, I started to do Java there. For every line in our input file, we need to trim that thing of all spaces and backslash ins and stuff like that, so we're just going to strip it. Line equals line.strip. We don't care if it has spaces anymore. We don't care. We don't want indentions and stuff like that to trip us up. Then we want to turn it into a number. Number is equal to float line, and then we can add that to our total. Total plus equals the number. And could we have done that all in one line by embedding things inside of parentheses, Yeah, that could have been done with one line of code.
That's better this
I'd rather write clear code than short code. Then we close our file and let's print out our total. Print total of, end quote, comma, file name, comma, begin quote, is, end quote, total. Okay. Save output to what file? Squares.txt. Sum the numbers of what file? I'm going to make a mistake. Type in something that doesn't exist because I want to see it. Say, could not open sdf.txt. Your program is still running. Do you wish to kill it? I suppose. Apparently the exit statement causes that dialog, that window to come up. Not really digging that. Don't know what to do about it. All right, here's what we're going to do about it. Up here, put file OK equals false. Got to make it with an uppercase F, excuse me. So above that, try. Tell you what, I changed my mind. Make it file OK is equal to true. Delete that line that says exit. I'm just going to comment it. And make it file OK equals false. And then we're going to put all the rest of our code in an if statement. If file OK, colon, and then tab all that stuff over. That way we'll only do that stuff if we actually open the file. If we got an error, we set that flag to false, and we won't do this stuff. And let's put our traditional done at the very bottom of it. Now test it both ways. Give it good file names and give it a bad file name. Good.txt is going to be my good file name. Now I'm going to sum the numbers of which file? Bad.txt. That does not exist. Could not open bad.txt, done. I like that better than it popping up that warning message. Do you wish to quit the program?
How did you tab all that over something?
I did a miracle. If you want to tab a bunch of stuff, you highlight it all, and you hit the tab key, or you hit format indent. Once you've tabbed it like that, it's a problem. So now I need to do a whole bunch of format dedents, or actually I'm just going to undo it.
Okay, because I thought if I did that, it would erase all the text.
You'd think. In other text editors, that can happen. Like if you're using Notepad, that could happen. If you're using Word, I'm not sure. But in a programming editor like this, or in Visual Studio or something like that, it's supposed to tab it over. So guess what the next assignment is going to do? What did Monday's assignment do?
Make the bar graph for,
Yeah, we counted all the letters. In this case, we want to count all the letters in a file.
Did you get this one to actually work?
I hope so. I haven't tried running it.
Because I tried running mine, I gave it a good file name.
Okay. Save out to what file? Good.txt. Sum the numbers of what file? Good.txt. And the total of all those squares is 33 billion or something.
Oh. So do you have
Oh,
to,
there we go.
you have to put in the same one?
Right, yeah. You better put in the same one or else it's trying to open some file that probably doesn't have numbers. So let's put some comments here. Because this is really a separate section of code right here. Get file name for reading. This section of code, open file. If file does not exist, set file OK to false. And then one more comment. If file OK, then read in each line, adding all the numbers to total. That's enough comments to clearly explain what that's doing. So let's set up the homework assignment, which is going to be to open a file and to do all that character reading, all that. In this case, we don't want to do it line by line. We just want to read the whole shebang in, all at once, and then count the characters in it. So let's call this one File 3. It's going to be similar to some code that we did in File 1. Whoops, I did a save as File 3. That was not my intention. New file. Save as file3.py. And you know what? We're going to do the same code that we did here to try to open the file. We could just copy it, or for practice, we could type it again. My name, my date, letter counter, number 2. Reads from file. So, file name is equal to input. Count the letters from what file? Now we're going to do file OK is equal to true so that we can prove whether it's true or not, whether it's good after we try to open it. Fn is equal to, what should the next thing be? I want to open this file and I want to open it for reading. Open parentheses file name. But that should have been in a try. So go up a level, add a try, tab that guy over, and then underneath that do accept, and we're going to print out our error message. Print could not open, comma, file name, and set file OK equal to false, capital F. It's too bad that exit didn't work right.
If you import sys, you can use sys.exit.
Yeah.
I am sorry, pardon me.
If you import sys, you can use sys.exit.
Oh, okay, okay.
Yeah, it is.
Smarty pants. So is it system dot or sys?
I think it's just import SYS.
Yeah.
And because the exit.
Sys.exit.
Yeah.
Alrighty, nice. I had forgotten. Copyright, clear, display, hook, all sorts of cool things, including exit. Alright, let's use that. Maybe we won't need this file OK flag. So add and import sys is our first thing. Why did I comment it out? And then sys.exit, parentheses and parentheses. I'm going to just put a print done down here. Count the letters from what file, whatever. I want to cause it to fail. Could not open. Okay, very good. Thank you. You earned the brownie points, which aren't as tasty as real brownies. I'm sorry.
So if that works, you don't need the file OK. right?
Exactly. We can get rid of this variable. We don't need our flag anymore. And we don't need file OK is equal to false. On the other hand, something we could do would be to loop over and over until they give us a good file name. But we're not going to make it too complicated. In which case you would not want to call sysexit. You know, you say file does not exist, you give them another shot at typing it in. Okay, now that we have that file, let's read it in. Text is equal to, how do we read in from our file? We're not going to read it line by line. We want to read in the whole shebang.
That would be file name dot, or
Yep. fin.read, yep. Shall we take all the spaces out?
Yeah, go ahead and share it.
Stripping would only take it from the beginning and the end.
Isn't there like R script or something like that?
Well, there's our, what we're going to probably want to do is run a replace on the text. Or remove all spaces from a string in Python. Yeah, that would do it. Let's give it a shot. Text.replace. I'm not liking this because it's still going to leave in the slash ends. So I'm growing disenchanted with this idea. But here's how you can replace all of one character with another one in a file. Let's just see what that does. Print that text and then close it. Fin.close. Let's see if that actually did remove all the spaces. Count the letters from what file? I want to use something that I know does have spaces, so I'm going to use our own file, file3.py, as our input. And what do you know, it didn't remove the spaces. Okay. I probably should have made it text equals text.replace. Let me see if that works. That removed all the spaces, but it didn't remove all the slash ends. Excuse me. Stop or I'll jump, you told me, but I didn't hear. Let's try the same thing with the backslash n character. Maybe by some miracle that'll work.
Do you want to call it another variable or the same thing?
Remove all slash n's from that text. And really the stuff we're doing here is kind of gravy. We could count the number of spaces and the number of backslash n's and stuff like that in the file. File3.py. There we go. I like that. So for your program to work, it doesn't matter what your input is, you know. You don't have to go and find a page of a text from a book or whatever. You're just going to be counting the number of characters in a file. So you can specify any file. I would say any text file. I don't know what will happen if you try to open a binary file. A binary file is one that is not encoded in ASCII text like this is. An executable is not a text file. Okay, so we've got all this stuff. We've got this text. What's next? We could add some comments here. Open a file, or get file name to open. Get file name and open it. I'm going to get rid of that print done. It's certainly not done at this point. Read the text in and remove all spaces. I don't think that's going to get rid of tabs. \T would. Remove all spaces and line feeds. Yeah, I'm going to copy and paste one more dot replace and get rid of any \T's, which are tabs. I'm not sure that we're going to find any files with those in them, but in case we do, we get rid of them all. Print the text, just for fun. You could get rid of that if you wanted to. We should have closed the file as soon as we opened it, or as soon as we read it. Close the file, and then the last part, the part that is pertinent to the assignment that you're going to fill in yourself. Use the string, use the data stored in the text string, count the occurrences of each letter, using your code from the prior assignment, the dictionary code, and draw a bar graph of the counts. So really, once you've done the other assignment, it ought to be remarkably easy to take that code and paste it into this thing to get it to draw the bar graph. Now, as we've gone, I've kind of forgotten about doing that business about the, if underscore name is equal to underscore main.
What was the point of that again?
The reason you do that is so that you can do an import and not have it execute that code. That bar graph code, you could import that function and then call it from here without even cutting and pasting it into here. But to get that to work, that bar graph function, the code would have need to have been written in functions and invoked from that code that looked like this. If underscore name is equal to underscore string underscore main, like that. Then run whatever your main code is, like that. So if I wanted this to look like that, I would add that to the bottom, and I would do define main up here at the top, and indent all of this stuff. It'll behave the same way. It just means that from another file, I could import this and it wouldn't automatically trigger. So if I had written my bar graph code to work like that, I could just add, import bar graph or whatever it was, and not actually have to copy and paste it. So I'm just doing this as kind of a reminder of that. We haven't been doing this since the beginning of the semester. Let me make sure I didn't break it. Cannot open. File3.py. Yeah. I see underscores. I don't like those. I'm going to replace those too. Nah, who cares? You could go to some considerable effort, at trying to get rid of all punctuation, but nah. I think getting rid of the spaces is enough. All right, guys, let's make a drop box. Let's drop all three of these in there. And I wasn't stopping enough to make sure that everybody was caught up. I apologize for that. If you didn't get one of the scripts going, let's get to work on it. Otherwise, we'll be done as soon as you upload it. File1.py, file2.py, file3.py. Alright, there's a Dropbox for it now. And this will be homework 11.
So for the third, or the last one that we did, what exactly is that supposed to do for?
That one you just typed in a sentence and it counted the letters in a sentence.
Oh, so it has nothing to, well,
This one, you're not going to ask them to type in a sentence, you're going to ask them the file name, it opens and gets the text.